classifier, image recognition classifier using CNN, Keras, and TensorFlow backend. This is going to be hands-on exercise, so I would suggest you to be ready with the Jupyter notebook and start coding. Step 1, we are importing libraries and splitting the data set. After importing the libraries, we need to split our data set into two parts, training set and test set. In our case, the data set is already split into two parts. So basically there is a folder where there are images of cats and dogs, and the data is already splitted into training set and test set, where each of the folders have a image of dogs and cats. The training set has 4,000 image of each of dogs and cats, while the test has 1,000 images of each. Cool. So we import models, then layers. So it will be model sequential, layers convolution 2D, max pooling 2D, flatten dense, and I'm just importing the warnings as well. Next is to initialize the CNN. CNN is convolution neural network. So classifier is equals to sequential. Convolution is basically to extract features from the input image. Convolution preserves the spatial relationship between pixels by learning image features using small squares of input data. So I'm adding a layer here. So add convolution 2D, input shape is equals to 64, and activation function is equals to relu. Same goes for this, and strides is equals to 2. Pooling, also called as subsampling or downsampling, reduces the dimensionality of each feature map but retains the most important information. This is the function for pooling, and I'm giving the pool size is 2 by 2. Flattening, the matrix is converted into a linear array so that to the input, the nodes of our neural network. So we add the flatten layer. Full connection is connecting our convolution network to a neural network and then compiling our network. So basically all the three layers, they are compiled into a neural network. So you can see my activation is equals to relu and activation is equals to sigmoid for the last layer. Compile, here we have made two layer neural network which with a sigmoid function as an activation function for the last layer, as we need to find the probability of the object being cat or a dog. So I'm giving optimizer is equals to Adam, loss equals to binary cross entropy, and metrics is equals to accuracy. Now it's time to fit the CNN to the images. So we are importing image data generator. So here we give the trait data generator these parameters and test these parameters. Then training set, here I have my training set, all the images. So this is taken from this directory, and for the test set I have a different folder named test set. So it found 8,000 images belonging to two classes and found 2,000 images belonging to two classes. So basically the images of dogs and cats. Then now I'm training my network. So I'm using the fit generator function. So on the training set, and steps per epoch is 8,000. So validation data is equals to test set, and validation steps equals to 800. So you can see various variables here. Loss is 0.3753, accuracy 0.8211. Now once my network has been trained, I'll test with a random image. So I actually downloaded an image of a dog and a cat from the internet and just saved it on my desktop. Now I'm testing that image and predicting the output based on what my how my network has been trained. So you can see here is the image. I'm loading the image and here I'm predicting the result, and if the result is greater than zero point 0.5, then it's a dog, otherwise it's a cat. So the first image that I have on my desktop basically is a dog, so it predicted correctly. Then I tested it for the cat, and this image is basically I downloaded from the internet, and it is a cat basically. So same function, I just change the image here, and it showed me the result as cat. So this is giving me right result. So this is all about image recognition classifier using CNN and Keras and TensorFlow. Thanks for watching. Stay tuned. Bye bye.